Welcome to another video from explainingcomputers.com. This time we're going to take a look at this, the Orange Pi Zero 3W. This is an octa-core ARM single board computer with a form factor that's very close to a Raspberry Pi Zero. So let's go and take a closer look. So here we have our Orange Pi Zero 3W, which came in a bundle with this active cooler as well as this mounting hardware for the active cooler. Why isn't this in the box with the active cooler? I've no idea. Anyway, this board was launched in April 2026 and is currently available with 4, 6 or 12 gigabytes of RAM, with this particular board being 4 gigabytes. For this and the cooler, I paid £54.85 plus taxes from Amazon.com, with my order placed in late May and arriving in early July. However, in the current market, prices are volatile, and at the time of making this video, AliExpress have the board priced from $85.27 for 4 gigabytes, rising to $170.96 for 12 gigabytes. Orange Pi also lists models with 8 and 16 gigabytes of RAM, but these are not on sale due, I imagine, to suitable DDR5 RAM availability. So let's open this up. Very simple, slide off the cover and take it out like that. In a little bag. Is it sealed? It is sealed. We'll have to bring in Mr. Scissors, waiting to get in like that. And yes, I've got in properly. I think I have. Well, almost have. We have our new single board computer, tiny little single board computer. And we should get out its cooler as well, as we've got it here. Also in a little bag, also sealed. Mr. Scissors gets 2 attempts. Let's go straight into this one, like that. And we've got the active cooler. And I don't think before I've seen an active cooler for a Zero form factor board, which is well, it's a first on this channel. And over here for comparison, I've got a Raspberry Pi Zero 2W. So if we bring in the Orange Pi Zero 3W and put it down next to it, we can see that it's got the same mounting holes, but it's very slightly wider. A Raspberry Pi Zero is 65 by 30 millimeters, whereas the Orange Pi Zero 3W is 65 by 32 millimeters, very slightly wider. In fact, let's use the magic of filmmaking to put them exactly end to end, and yes, we can see the Orange Pi is clearly a wider board. And I also think we should compare the Orange Pi Zero 3W with this single board computer. This is the QB A7S that I looked at on the channel fairly recently, and the reason I think we should compare these two boards is that they're both based on the same system on a chip, which is an Allwinner A733, and they've both also got a PCIe 3.0 interface. So these SBCs are very much alternatives, if with differences. Not least, we've got a mini HDMI port on the Orange Pi Zero 3W, whilst we have an Ethernet network connector on the QB. And with this noted, let's now have a full hardware rundown of the Orange Pi. As just mentioned, at the heart of the Orange Pi Zero 3W is an Allwinner A733 system on a chip. This has 2 ARM Cortex A76 cores clocked at up to 2 GHz, together with 6 ARM Cortex A55 cores clocked at up to 1.8 GHz. There's also an Alibaba RISC-V Zante E902 microcontroller core clocked at up to 200 MHz, as well as an Imagination PowerVR BXM464 MC1 GPU and a 3-TOPS NPU. Next to the SoC, we then find the RAM, here 4 gigabytes of low-power DDR5, and next to that, a wireless module which offers Wi-Fi 6 and Bluetooth 5.4. And for this, there's a connector for the provided external antenna. Finally, on the top of the board, we find a power management unit and a 40-pin color-coded GPIO connector. Turning to the main long edge, we first find this USB Type-C connector, and this provides USB 2.0 data connectivity, but is generally used to power the board via a 5V 3A supply. However, 5V power may alternatively be provided via GPIO. Next, down here is an indicator LED, and then the second USB Type-C connector, and this one provides USB 3.0 data connectivity, as well as supporting video output via DisplayPort Out mode at up to 4K at 60 frames a second. Finally, we have this mini HDMI connector, or in other words, the kind of small HDMI connector that actually works reliably and which also supports 4K output at 60 frames a second. And so, the Orange Pi 03W is a zero form factor SBC which supports two independent displays, which can be useful for things like digital signage. And you may now think we've all but finished. But no, as underneath, if we take a look, there is far more connectivity than we could rightly expect. For a start, we have a microSD card slot that supports a card up to 128GB in size, and at the other end we have this, which is an FPC connector like the one found on a Raspberry Pi 5, and which provides the single-lane PCIe 3.0 interface that I mentioned earlier. However, note that Orange Pi do not claim that this supports an NVMe SSD. And indeed, in the board's excellent 281-page manual, there is nothing whatsoever about the PCIe interface. Moving on, in addition to the microSD card slot and FPC connector, we have not one, but two 4-lane MIPI CSI or camera serial interface connectors for connecting cameras, as well as a 4-lane MIPI DSI or display serial interface connector for hooking up an LCD panel. In addition, there's a 2-pin fan connector here for the active cooler, and down here we have header pads that allow the connection of external power and boot switches. Finally, over here there are pads for both UFS and eMMC, which in theory allow the board to be supplied with up to 128GB of onboard flash storage. But I'm not aware of any such configuration being on sale. And so let's turn the board back the right way up. There it is, that'll make it happier. And we'll now go in search of its cooler and mounting hardware. And if we fit this, we're now all ready to see how the Orange Pi 03W performs. Greetings! I've now got the board all connected up. It really is a very nice little unit with the heatsink fitted. It's got a bit of weight to it. And specifically here it's connected now to a Raspberry Pi 4 power adapter, to a monitor via the mini HDMI connector, and via this USB-C to A adapter it's connected to a keyboard, a Raspberry Pi keyboard, which contains a hub to which I've connected a mouse. So let's turn on the power. There we go. There is a tiny little LED back here. I don't think you can quite see it on camera. The fan has come on and it's a very, very quiet fan. And what we're booting into here is Ubuntu on a microSD card, specifically an image of Ubuntu 22.04 or the Jammy Jellyfish with an XFCE desktop. And this image is provided by Orange Pi, and it is an April 2026 image. However, Ubuntu 22.04 is only supported till April 2027. Note that this is not my first boot, as I've already gone in and made a few scaling changes, but other than that, this is what you get straight out of the box. And what we have here is nice and responsive. I like this system. Let's just bring up, for example, the file manager. You can see this is a nice system to use, perfectly usable small desktop computer. Lots of things pre-installed, loads and loads of settings as we get in XFCE, plus the Orange Pi configuration program. Let's just launch that. Comes up in the terminal. We need to enter our password. Orange Pi by default, have I got that right? Looks like I have. And there's lots of stuff here, lots and lots of system settings, CPU, hardware, turning things on and off, that type of thing. control of network stuff, all very handy to have here on a single board computer. And we also have here a software section, which I rather like, and this allows us to add certain software that isn't pre-installed, things like GIMP, LibreOffice, either with just LibreOffice Writer or the whole LibreOffice suite. And we've also got here, for example, a monitoring application, which will show us our temperatures. This board does get hot. The heatsink on the board after half an hour is quite warm. The whole board is quite warm, but we can see the temperatures are about 50 degrees, which isn't too bad. So there we are. You certainly need a heatsink on the Orange Pi Zero 3W. Let's continue down in the menu. Various accessories are here. For development, we've got Genie. Under graphics, we've got a document viewer. Under internet, we've got the Firefox web browser. Under multimedia, we have the VLC media player. Under Office, just a document viewer, hardly a surprise given what we've just seen about installing LibreOffice. And then finally under System, we have loads and loads of things. Let's bring up HTOP. There are lots of you like to see HTOP, so here is your HTOP fill for this video. We can see our 8 CPU cores, our 4 GB of memory and what's going on. All very exciting. As you probably gathered, I like this system. It's a nice little computer. And of course, we should see what happens when we do launch a web browser. Let's bring up Firefox. I'll show you everything in real time. Remember, we're running here from micro SD card, but it's perfectly usable. Standard sort of web browsing stuff is, nice and responsive. There's no doubt at all you could use this. I've also preloaded the WebGL aquarium, which is not that impressive. With only 500 fish, we're getting about 8-9 frames a second. I don't think we have any form of hardware acceleration for the GPU here in this image. The fans that come on the board, it's as if the fan wasn't already. It's gone a little bit faster now, the fan, but still nice and quiet. But anyway, we'll close that down because, of course, I want to go across to YouTube and do a YouTube playback test. And it is worth noting that according to the manual for the Orange Pi Zero 3W, the only operating system that Orange Pi supply for the board that has got GPU hardware acceleration is the one based on Debian 11, which is end of life now and ceases support a few weeks after this video goes live, which is why I thought I'd initially test this Ubuntu image. Anyway, let's try YouTube playback, see how good it is. And take it up full screen and just check what we're in. We will start with 1080p, which looks quite viewable actually. The browser is quite responsive here compared to many we get on single board computers with very little support. That transition was very good, but we are dropping a lot of frames as we can see up top. Let's drop down to a 720p, should make things better. Still viewable as it was previously. We're still dropping a few frames. So always interesting when things look okay, but clearly, again, a good transition there, but we are dropping frames. Anyway, that was just an initial first look around here in Ubuntu 22.04. Right. You may have been curious, I was too, about what was written in the manual, and so here we're now running Debian 11, Debian Bullseye, and it's very similar to what we got with Ubuntu, exactly the same XFCE desktop. The only major difference is, it seems, we've got two web browsers here, Firefox, in which video playback is just as bad as it was in Ubuntu, although in Chromium it is slightly better. And let's just take a look in Chromium. I've got it preloaded. And I've got actually here, before we take a look at performance, the web pages for the Orange Pi Zero 3W. I just wanted to show you the downloads that are available. Here they are. In theory, there is an official image for Orange Pi OS, although if they go across to the links they provide to Google Docs, there are no image files there for Orange Pi OS. We'll take a look at Ubuntu, which we were just running. Specifically, we were just running the second image here, Ubuntu 22.04 with Linux kernel 6.6. And if we take a look at the Debian images, here we are. Remember, it told us Debian Bullseye, Debian 11 had got GPU hardware acceleration. So here we're running this image over here, Debian 11 with Linux kernel 6.6. But unfortunately, if we look at the GPU internals, there is no hardware acceleration whatsoever. Even WebGL is disabled, which means if we go across to the WebGL aquarium, guess what? It doesn't work because we haven't got WebGL. This all said, we just close those down to give it the best possible chance. We go to YouTube and we do some playback. We won't have hardware acceleration for the GPU, but we do get better playback than we saw in Ubuntu. Let's just bring up stats for nerds. And there were a few drop frames at the start, but now things have settled. We are playing 1080p without any drop frames. So this is better than we saw in Ubuntu, if you want to be running a completely non-supported operating system. Anyway, I just thought it was worth having a look at that because of what it said in the manual for the Orange Pi 03W. Right, back here in Ubuntu, I thought we'd run a few more tests. Let's start there with an LSBLK, list block devices. We can see the storage on the system. Here is the microSD card, so you can guess what's coming next. We're going to test its speed. There's the command in the buffer. Let's see what we get. Need to put in my password. What's it going to be? Oh, it's exciting, always exciting. And there we are, 65.74 megabytes a second. A little bit slower than I'd like. I'd like it more towards 80 on a single board computer, but it's still faster than many an SBC I've tested in the past. So let's clear the display and we'll bring up in the buffer this CPU sysbench test I've used many times before. It's going to factor prime numbers to a maximum value of 20,000 using all of the cores, all of the threads on the system with an events limit of 10,000, which means in practical terms it'll take a few seconds to run. So let us run the test. Here we go. What result are we going to get? There we are, 2.69 rounding to 2.7 seconds. And this result is pretty meaningless in isolation, but if we compare the result to previous tests I've run on a Raspberry Pi 5, a Raspberry Pi 4 and the QB A7S, we can see that the Raspberry Pi 5 completed the test in the fastest time, 2.43 seconds, compared to 2.27 seconds on the Orange Pi 03W, which is slightly faster than the QB A7S on 2.84 and significantly faster than a Raspberry Pi 4 on 3.59 seconds. And particularly here it's worth noting that the Orange Pi 03W has come out very slightly faster than the QB A7S, and this might be due to operating system implementation, something like that, but it could also be because we've got a better cooling solution on the Orange Pi than on the QB, which perhaps was throttling towards the end of the test. Anyway, we don't know and the results are very close, could just be experimental error. But having talked about cooling, let's just bring up a script that's included here on the Orange Pi 03W, which is this. And if we execute it, we can see the temperatures of all the different zones, different sensors available, and they're all roughly around 50 degrees other than the skin zone down there at 34. And the reason I brought that up is because I've got a power meter attached to the computer. We can see right now at idle we're using about 3.1 watts, 3.2 watts, something like that. But I want to stress things out so we can see how much power we're using. We'll return to our temperature test after that. And what I'm going to do is to bring up again the sysbench test. We'll just make it run for about 20 times longer. In fact, just to make sure it really will, let's also put up the max prime value as well, like that. And now repeat the test. Here it goes. And we can see power use going up immediately. 6.5, 6.6 watts, something like that. Certainly using a lot more power. So anyway, let's speed on through until the end of this test. And here I am back again. The script is still running. It's always difficult to gauge exactly how long sysbench is going to run when you increase the parameters. It's not a linear relationship. So what I'm going to do is just to stop the test with a Control C, and then we're going to go straight into the temperature check like that. And that's very impressive. The cooler's clearly doing its job, not getting much beyond the high 50s. I'm very impressed with the cooling solution here on the Orange Pi 03W. We can certainly now smell that smell of hot electronics. And I guess that the heatsink is, yes, it is almost too hot to touch. Guess what? We've got a surprise ending because, as you can see, I've connected up a Raspberry Pi NVMe SSD adapter board with an SSD on it to the FPC PCIe interface on the Orange Pi 03W, And I did this because I expected to say at the end of the video, I've tried this, here's a shot of it, but it didn't work. But guess what? It does work. The fact this isn't mentioned in the manual doesn't matter at all. So let's go across to the desktop, and here is Stanley, our NVMe SSD. And if we just bring up a terminal, let's first of all do an lspci, where we can clearly see the SSD. And if we do an lsblk, here it is, there is NVMe 0 N1. And of course we will do a speed test. Let's just get the screen clear first to be tidy. Bring it up in the buffer. And here we go. Remember, this is a PCIe 3.0 single lane interface, but we'll get 581 megabytes a second, a very respectable speed for an SSD on a low-cost single-board computer, particularly one where NVMe SSD support isn't even listed by the manufacturer. The Orange Pi 03W is a nice little SBC that offers considerable power and decent connectivity in the 0 form factor. Software support could certainly be better, but I still think that this is a board that the maker community has got good reason to embrace. But now that's it for another video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe, and I hope to talk to you again very soon.